Welcome back to our channel. Today, we're diving deep into a fascinating question. Is time travel possible? Let's explore what science has to say about this topic and uncover the mysteries surrounding it. Time has been a concept that has captivated humanity for centuries. In countless works of science fiction, from Doctor Who to Back to the Future, time travel is an essential element. But the real question is, can we actually make such journeys in real life? The short answer is yes, and you're doing it right now. That's right, we are all moving into the future at the rate of 1 second per second. Whether you're watching paint dry or wishing you had more time to visit a friend, we're all moving through time at the same speed. But this isn't the kind of time travel we usually think about when it comes to movies or books. In the realm of science fiction, we often see characters step into strange machines to travel to the past or the future. These journeys bring up questions like, what would happen if you change the past or use information from the future to alter the present? But how does this play out in reality? While many people are fascinated by the idea of changing the past or seeing the future before it happens, no one has ever demonstrated the back-and-forth time travel seen in science fiction, nor has anyone proposed a method for sending a person through significant periods of time that wouldn't destroy them along the way. As renowned physicist Stephen Hawking once said in his book, Black Holes and Baby Universes, the best evidence we have that time travel is not possible and never will be is that we have not been invaded by hordes of tourists from the future. However, science does support some amount of time bending. For example, according to Albert Einstein's theory of special relativity, time is an illusion that moves relative to an observer. An observer traveling close to the speed of light will experience time much more slowly than someone at rest. This is why astronaut Scott Kelly, who spent a year in orbit, aged slightly less than his twin brother, Mark Kelly, who stayed on Earth. GPS satellites, for example, have to adjust their time because of this difference. When satellites move at high speeds in space, their time moves slightly slower than time on Earth. To ensure precise positioning, engineers must calculate compensations for these differences. There are also other scientific theories about time travel, including ideas involving wormholes, black holes, and string theory. But for the most part, time travel remains the domain of science fiction books, movies, television shows, comics, and video games. Einstein's special relativity theory, developed in 1905, along with his later expansion into the general relativity theory, has become one of the cornerstones of modern physics. Special relativity describes the relationship between space and time for objects moving at constant speeds in a straight line. So, why is relativity important to the idea of time travel? First, all things are measured relative to something else, meaning there is no absolute frame of reference. Second, the speed of light is constant, no matter where it's measured from. And third, nothing can go faster than the speed of light. From these simple principles, real-life time travel unfolds. An observer moving at high velocity will experience time at a slower rate than someone not moving quickly through space. Although we can't accelerate humans to near light speed, we can send them around the Earth at 17,500 miles per hour, 28,160 kilometers per hour, aboard the International Space Station. This demonstrates that time can be bent and flows differently depending on an observer's speed and location. So, if you're thinking about time travel as a way to live longer or travel to the distant future, that's still a long way off. But effects like the slight time difference between GPS satellites and Earth show that these concepts can be crucial to modern technology and science. NASA also states that general relativity could provide scenarios that allow for backward time travel. But the physical reality of those methods isn't exactly easy. Wormholes are hypothetical tunnels through the fabric of space-time that could connect different moments or locations in reality. However, no wormholes of any kind have been identified in real life. Other theories, like astronomer Frank Tipler's Tipler cylinder, involve taking matter that is 10 times the sun's mass and rolling it into a very long, dense cylinder. When spinning this cylinder at billions of revolutions per minute, a spacecraft nearby could travel back in time on a closed time-like curve. However, the main problem is that for the Tipler cylinder to become a reality, it would need to be infinitely long or made of some unknown type of matter. Another idea is the time donut proposed by theoretical physicist Amos Ori. He suggested a model for a time machine made from curved spacetime, a donut-shaped vacuum surrounded by a sphere of normal matter. But this, too, is purely hypothetical because the ability to manipulate gravitational fields at will is still beyond our reach. So, while these theories open up many exciting ideas, the possibility of real-time travel remains a dream for a distant future. Thank you for watching this video. If you love exploring science like this, hit the like button and subscribe to our channel so you won't miss any of our exciting future videos.